Okay, so hello again, everyone. And as you already see from the title of the presentation, is that we will be talking about principles of forming fees in Bitcoin. This is a rather important topic and the one we have been preparing for all of this time. First, when we have learned about basic principles of Bitcoin operation. Then when we dug a little bit deeper, even touched this topic a little bit. And today we're going to tie everything together. It may be a little bit difficult to grasp everything from the get-go. So do not hesitate to ask questions even as I am going. Please write your questions in the chat. We have our great team here assisting me as usual in answering your questions in the text form. But anyway, let's start. So the first question that we need to get out of the way is who sets the fee, the rate of the fee, right? Because we have already talked quite a few times that Bitcoin is a decentralized network. Bitcoin is decentralized network, which has no central entity, no government, no CEO, nothing. So the fees are set in the same way, in a decentralized way. So there exists no center that would set the size of the fee or the rate. And the protocol has no strict rules and no rules at all for calculating the fee. The user themselves set the size of the fee when they form a transaction. And as it is stated in the protocol, the fee can be from 0 to any number you can think of. So the only requirement is that fee cannot be negative, because it would be quite strange, and it would even defy the common sense if the fee would be negative. So yeah, now that we are clear on who sets the fees, let's have a brief reminder of the high-level structure representation of a transaction. So as you remember from previous lectures, the transaction has a header and two main parts are the input coins and the output coins. The input coins are the source of from where you are getting these coins, and output coins are specifying where do you want to send these coins. And you will get why this is important in a minute. The fee in Bitcoin is set as a difference between the output and the input coins. So here again, we look at the schema, we have the input coins and the output coins, and the difference between them is considered to be a fee. So the amount of output coins of a transaction must not exceed the amount of input coins, because it would violate the rule that transaction fee cannot be negative. And users themselves set the amount of fee based on this difference. So let's say you have 5 coins, but you only need to spend 2 of these coins. What you do is you create a transaction which has one input specifying where did you get your 5 coins from, and it has 2 outputs. The first output sends 2 coins as a payment or as a transfer to your friend, whatever, for the main purpose. And you send the remaining 2 coins to your own address as a change. You want to get the change from this transaction. And then the remaining 1 coin will be the fee, because your input is 5 coins, your output is four coins, and the difference, 1 coin, goes to the validator node as that transaction fee. The fee itself, and basically here we will answer the question, what are you paying for? Why would you even need the fee? And what's the point of having a fee in Bitcoin? First of all, the maximum block size in Bitcoin is limited to 1 megabyte or 1 million bytes. So this is a pretty precious real estate we are dealing here with. If the flow of new transactions exceeds the available bandwidth, which is 1.7 kilobytes per second, which is not too much, especially considering how many transactions and how many users Bitcoin has right now, then obviously not all of these transactions will be processed. So the fee allows the user to place his bid in this auction. So users who are willing to send transactions and store something in the Bitcoin are betting to for this place, and the more you bet, the more likely the transaction will be included in the next block. Since Bitcoin works with blockchain as its as one of the cornerstone technologies for it, the very valuable properties are immutability and indestructibility. So that's why you are paying basically for each byte of your transaction to be written into this immutable and indestructible database, which is a very, very precious real estate. Basically, you're not simply paying to store your transaction bytes on one machine, like on one server, for example. When you, I don't know, put some file in the cloud, for example, you are paying some very, very tiny amount of money because it's cheap. Servers has most of the servers and cloud entities have so much available free space on their drives that it's basically dirt cheap to store almost anything in the cloud. But blockchain is expensive to maintain because you have dozens or even hundreds of nodes all keeping the same copy of the database, and all of them need to maintain, or well, in any way they need to maintain this pretty significant amounts of data, and this is quite expensive. So this is what you are paying for. You are paying for these properties of immutability and indestructibility when it comes to your transactions, when it comes to you transferring something to someone and recording this fact in the blockchain. So you may ask, if everyone can set the arbitrary fee, then how do I know what fee should I set? How do I don't shoot too high or shoot too low? Because I don't want my transaction to be lost at the bottom of the mempool and maybe never be actually executed. But on the other hand, I don't want to overpay and to lose my fortune just when I want to send a few coins to my friend. To tackle this issue, most of the wallets, the software for the wallets implement the mechanism of flexible calculation of the fee, which covers not only the question, the question, how much do I pay, like in theory, but how much do I pay considering the volatility of the
Seems like connection is lost, or can someone hear him?
No. Okay, one moment, please. I know Alex have problem with connection, but I know that Alexander has opportunity for change. For Alex, one moment. It's okay.
So, yep, when we want to calculate transaction fee, we can just multiply the transaction size by byte price. So you will pay for each byte of your transaction, and it's obviously that validators can select your transactions and can put them in their block. And I'm, as a validator, I'm looking for the most efficient way how I can put transactions of other users in my particular block. And for me, yes, it's obvious. It makes sense at only like valuable transactions. So transactions that paying like most efficient fees. Okay, so yeah, it's very, very important to divide like full process into three particular sub-processes. So the first one, it's like transaction creating. So you can create transaction locally without involving validators, Bitcoin network itself, etc., etc. So you just should create some like digital structure and sign that with your digital signature, and later just send it, I don't know, transfer that offline without like an internet connection, or send it in Telegram chat or using like your Bitcoin wallet and so on. It doesn't matter, but that's like the separate local process when you're creating your own transaction. Later, there is a process of processing or verification of the transaction. It means that any validator, any auditor, and any user in the system can verify that your transaction is true. It means that it can be processed due to rules of Bitcoin protocol. It means that you shouldn't create additional coins from air. You shouldn't try pay twice with the same money. So it's like global verification process when everybody can verify that your transaction is correct, technically correct. And the last step is a transaction validation or transaction confirmation. It means that particular miner or validator can take this transaction and put that into his block. So when I have some like mining equipment and I want to create a new block and add it to exist like blockchain history, I can put any transaction from the network in my block, like for any reason. Really often it's like amount of fee, and later just when I create the correct block, when I like mine that, I'm validating the transaction itself. And when this block is created and when it's added to the blockchain history, everybody can verify that this transaction is valid because it's included in the main chain of the Bitcoin network. Okay.
Okay, Alex, can continue?
Okay.
Yes,
So,
thank you, Alexander, for taking the lead while I was sorting out whatever have just happened. But yeah, I think we are ready to proceed. So,
okay. So I'm stopping to share my screen.
Yep, I will hop on right at the moment you have stopped. Okay, so we are clear with this part and we are moving on. So proceeding with this whole metaphor about the auction and the limited space, we can imagine the fee mechanism as the block is the bus which of course has limited spaces. And transactions are the people who want to get on the bus, and the station where they are hanging out is the mempool. So each of them is ready to pay a certain amount of satoshis, because it would be too much to pay in Bitcoin. So each of them is willing to pay some amount of satoshis, and generally the ones who pay the most will be the first to get on the bus and to get to their destination, which is blockchain. This allows to this creates the mechanism where you pay for the work of the network. So the network does not run out of charity, but you are paying for validators to keep it running and to store your transactions in immutable and available to everyone form. So when it comes to processing transactions by validators, each validator node queues all unconfirmed transactions in such a way that it first takes transactions that pay a large fee per unit of their weight. So this is the lever you can use to manipulate the time when your transaction gets confirmed. Since you cannot really manipulate the size of the transaction unless you are willing to drop something out of it, the best way to speed it up is to increase the fee per unit of the weight. Of course, these transactions that are at the bottom can be unconfirmed either for a very long time or can be unconfirmed for theoretically eternity, because they are laying at the bottom and everyone else is just adding more transactions that have higher higher proposed fee than this transaction. So they will be there for a very, very long time. Another problem that fee mechanism solves is the so-called tragedy of the commons. Overall, the tragedy of the commons refers to a situation when certain public resource, which is called a common, is used by people solely in their interest without caring too much about depleting this resource. A few examples of natural commons in this problem include coffee consumption. Even though the cup of coffee you drink in the morning does not make too much of a difference, but on the large scale, coffee is considered to be a naturally occurring resource, which is, if consumed in a very large quantities by a large amounts of people, can be quickly depleted and well, it will quickly become scarce. The second problem, which is quite similar, is overfishing. Again, if humans do not care much about how big is the population of fish in a certain region, they will simply destroy this part of the ecosystem, and well, they will be left without the fish for the reason that they are focusing too much on their sole benefit and on their own convenience. The third example is a fast fashion. Brands are creating so many new types and items of clothing that many of them even have to burn the stockpiles of their items in order to free up the warehouses. They have so many items that they cannot simply fit in the warehouse. And you do understand that doing that is harmful, not only for the economy, but also for the for the ecology of and for the future of our planet. When it comes to Bitcoin, the tragedy of the commons is the access to the network and the way you use the network. Without the fee, people would simply crash the network very, very quickly. It would be an unintended DDoS attack, and the nodes wouldn't just be able to process all of these transactions if there was no fee and no way to range and choose which transactions to process. And of course, the fee mechanism acts as the means of stopping the attacker by making it too costly for them to execute a denial of service attack for the Bitcoin network, because if the price of conducting an attack is higher than the benefit from this attack, then generally we can consider that the system is safe from this specific attack. And this is the case for Bitcoin. We have already mentioned volatility today, but very briefly. So let's stop and pay more attention to the question of volatility in Bitcoin. What we are referring here is not the volatility of the price of Bitcoin compared to other assets like US dollars, euros, and other cryptocurrencies. What we are referring to here is the volatility of fees, how quickly they change depending on the load on the network. One example is in 2027, the average price of writing 1 byte of data in the Bitcoin ranged from 1 to 500 Satoshi, so which is a huge range in reality. The reason why it what it led is that unconfirmed transactions used part of the kilobyte before the transfer, and even hundreds of megabytes. So the bigger the workload, the bigger the number of transactions, and the bigger the number of users trying to simultaneously send Bitcoin transactions, the higher will be the fee, because whenever we have something limited, some limited resource or some limited threshold, basically the proposition is limited, but demand is growing. And whenever proposition cannot meet demand, the price of this resource grows, because the resource itself becomes more scarce for all of the people who want to use it. And this is the same case for Bitcoin. Since the price of this process of recording the data can change dramatically, users basically can compete almost blindly with each other. So whenever you are sending a transaction, you are not really thinking about other people who are also sending transactions in the network right now. You don't ask yourself how big is the workload right now. You have a need and you want to satisfy this need. You want to send a transaction, complete the transfer of your coins to another person, and this is what you care about. And the mechanism of fees, regardless of how volatile these fees can become, protects the interests of users like you by ensuring that the system will be operating even under high workloads. So, and on this slide, we have a small graph which represents the relation between fees and load on the system. So on the y-axis, we have the amount of bytes per second, which is a unit to estimate current load on the system. And here we have the average Satoshi per byte. And again, a reminder, this is empirical data. So we are not talking about rules, or we are not talking about protocol which enforces that if the number of bytes per second is higher than this number, then the number of satoshis per byte should be this value. No, again, this is empirical data which represents the self-regulating nature of Bitcoin network. So if we are to look at the first threshold, which is 1,700 bytes per second, this is the capacity of Bitcoin without segregated witness update. And the price in this range is, well, basically they can be, the transactions can be even free. So if the network load is so low that no one is adding new transactions, or almost no one is adding new transactions, then these transactions can even almost become free. And this is likely what was going on when Bitcoin only launched, and there wasn't so much of the volume of making transactions in the network. When the workload rises a little bit, so is the number of Satoshi per byte you need to specify in order for your transaction to be confirmed in a timely manner. Of course, you always can go sky high and be the first one, but lose a lot of money, or you can cheap out and go somewhere in this range, or even in this range, but you risk your transaction to be not included in the blockchain. And if we have even higher workload, which is 3,000 bytes per second, which is above the capacity of Bitcoin with full segregated witness adoption, and it goes sky high, then the number of Satoshis per byte you need to provide in order for your transaction to be added to the block is from 1,000 and to infinity. So if the workload is so big that everyone on the planet, including elderly and toddlers, would want to send a transaction to Bitcoin simultaneously, then we probably would have some kind of a situation like that, when the overall price of the transaction is infinitely big, or at least very, very, very big. So we also have one interesting example, and let's stop and spend some time to properly go through this example. So since the validators are not strictly obliged to choose transactions according to a certain rule, and the price ranging is more of a convention than the rule, then in theory you could, well, if you have some friend miner, you can influence their decision and ask them to give some priority to your transaction. So what do we have here on the example, in our example? So we have a transaction which is has some size, and it has fee of 0 Satoshi. This transaction has a friend miner who operates a Bitcoin node and performs validation of transactions, and they want to cheap out. So basically, I want this transaction to have 0 fee. I don't want to pay the fee, but I can provide an alternative means of payment, for example, candies and wine, so that my friend miner gives a priority to my transaction. The way it works is this miner has a certain computational power in the relation to the whole network. So let's say their computational power is 10% from the overall computational power of the network, so which is actually quite big for a single miner. So I go to them and I give them this beautiful gift and ask them to confirm my transaction. I tell them, look, this is a beautiful transaction. You have to confirm it. It has 0 fee, but don't worry. I brought you some wine and I brought you some candies. They say, okay, I will validate your transaction and I will include it in the block. So the way it will work is that for each round, this miner will take our transaction, put it in the block so it will be the first transaction that this miner puts in the block. Then they fill the block with the rest of the transactions, for example, ranging them again by price from the highest paying to the lowest paying, and it tries to propose the block. Since they have this 10% of computing power, the moment they successfully complete proof of work, and the moment they are the one who adds a new block to the blockchain, our transaction will be included. So, but this is not a silver bullet, and you will still have to wait, but your time of waiting maybe will be a little bit more predictable, and also you can provide alternative means of payments. A more complex example of how it could work is when we imagine a group of such miners who combine their computing power, and well, what they do is they provide this service when you can have a transaction with 0 fee, and you can buy one ticket for your transaction to be added to the blockchain. And this ticket is basically a tokenization of the priority for this pool of miners. So you always pay a predictable price, and you agree on the term that you will have to wait a certain time depending on the overall computing power of this group of miners. But for you, it is better because you always pay one price. For them, it is better because they get the money, and well, they still can validate other transactions. So you basically buy one token for putting your transaction in their block, and when you want to redeem this token, you give the token back, and your transaction gets included in the block. So, and this is it for this example, and let's see what questions do you have left.
All the answers are given in the chat. Please your new question.
Yep. If anyone has additional questions, now is a good time to discuss them. Is it fair to deal with my friend miner to other participants? Yes, there is, well, the protocol does not prohibit that, and if you are talking about the moral side of things, then I'm not sure. But if you are talking about the whether it influences the operational capability of the network, then no. It could, in theory, interfere with how the network operates if you were trying to push some malicious transaction, and let's say your friend has modified version of the software so he can accept your malicious transaction and give it and send it to the network. But that this is the reason why we have other validators who would not accept this transaction. So this wouldn't work out in the end.
Just one more question about this. So basically the protocol and the system doesn't control how the validators acting through the transactions. I mean, like, for example, you have a super rich client with a lot of coins, yeah, that takes a lot of Ether or something like that, you know?
You mean
Like
the bandwidth? He takes up a
yes.
lot of bandwidth. Mhm.
Like he take a lot of attention, you know, and the other person, other participants can't do their own stuff. They need to wait.
Yeah, I see. So you mean we have again this group of friend miners who agree to give priority to our transactions, and we have a very big amount of transactions. So we have thousands of transactions. But the problem here, if I were this rich person who would want to push this approach, is that I would, well, still the computational power of my friends would be limited. It would be it would very unlikely be enough to take over the whole network and to steadily publish new blocks, because if they were able to do so, they would just be able to do whatever they want if they control the majority of the computing power. If we try to basically buy the whole network and just spam it with very expensive transactions, then you will very quickly run out of money, because you will bid against yourself and you will need to constantly raise the price for your transactions to be more and more and more in the priority. So you will be bidding against yourself.
Oh, okay, got it, the idea. Okay, thanks a lot.
Yep, thank you for the question. So we still have quite some time. So if you have any questions, do not hesitate. Now it's the great time to ask them. Okay, and yeah, I see Igor Zhukov, please.
Sorry, I didn't want to get like a specific example. Who is validator and who is miner? Because I know some of my friends were miners. They bought this expensive, like powerful computers, and they mine. Understand they are miners. They process adding new blocks. And who is validator who form these new blocks depending on fee?
Yep, I see what you mean. So if we just briefly mentally take a step back to one of the previous presentations we had, is, well, the validator is the participant of the network, and the validator runs a stack of software on his hardware, which is just hardware. And this software includes different modules. One of them is network module. One of them is validating module, and one of them is the miner module. So the example we had on the slide is a little bit of simplification just for illustrative purposes, but following the terminology, the miner is not a person, is not a participant, is the part of the validators activities, mining the blocks and the part of the modules that validator has in order to fully participate in the network.
Thank you.
Yeah, and it's very common to see it when you read like whatever articles or news. Many outlets confuse these terms and they call miners that people, miners who are people or miners who are companies. But yes, as also the comment from our team in the chat, right now miner is the actual hardware. What I forgot to add is that it's also the hardware. Right now it's ASIC hardware, which performs the computations, which actually performs these computations that are necessary in order for the proof of work to follow the proof of work process. So yes, thank you for this correction. I have totally forgot about this. Yep, I see question from Anton Mishenko.
Hi there. Just wanted to ask if you have any predictions or just thoughts in general on how the transaction fees might change in the future, either go up or go down with the, any possible changes in the cryptography itself in the Bitcoin protocol and any other technological advancements that the Bitcoin protocol might have. So how would that affect the transaction fees going forward?
Yeah, thank you. This is a quite interesting question, but first of all, it's pretty difficult to try to predict and to envision things like that. There are many ways to do so. You can try and have a statistical model. You can have some even machine learning model if you are feeling fancy and want to have these kind of predictions. But what I would say is that right now we are probably not in the right position to make any kinds of predictions, especially in the as part of this learning material. So I'm not trying to say that your question is invalid or it shouldn't be asked, but I just want to avoid the situation when we mistakenly mislead people and unknowingly use our position as the people who are sharing the knowledge to provide some predictions which are not really based on anything except our some experience, thoughts, or simply our speculations. So it's a great question, but I would leave it out.
Maybe I can rephrase it slightly, or maybe it would still be the same question, but I'll still try. What I'm referring to is this relation between the way Bitcoin kind of makes money for a lot of miners is that they now get a certain amount of Bitcoin per the block that they record onto the blockchain, and that amount goes down every 4 years, right? With a halving, the amount of money miners make through this process becomes less and less and less. So I guess my question is like, will miners be hoping to get more money through transaction fees? Maybe like that's the vision for the future of the protocol. I guess it's still the question about the future, but maybe based on the past experience with the Bitcoin, halvings and everything, has there been, substantial growth in the transaction fees so that we could kind of extrapolate this into the future and say that, hey, possibly the fees will grow, or we haven't seen anything like this based on our experience, so we can't say. Do you see what I mean? Sorry, it's a complicated, I'm trying to formulate this correctly, but it's just a bit hard.
Yeah, I see where you're coming from, and yeah, so again, there's not much we can speculate about, but looking in hindsight at what has been happening with Bitcoin over the course of these years, is what can we say for sure is that Bitcoin is a very lively, very dynamic, I wouldn't even call it, well, let's stick to the formal definitions. It's a very lively, very dynamic system, and the technology is very dynamic. So since the protocol is not absolutely fixed in stone, and it has the capability of being upgraded, and many questions are either have been addressed previously by the community and the developers of the Bitcoin protocol, or they are in the process of being addressed, or they will be addressed sooner or later. And this includes things that optimize the workload, things that relate to cryptographical improvements, and so on and so on. So this can be absolutely different changes, right? But Bitcoin has this ability to change, even though it's not as easy as updating an app on your phone, where you just press update and it's immediately on your phone, and the service does not care whether you have updated or not. It's your problem because you are not doing anything. If you are running, if I don't know, I have a Twitter on my phone, and if it's very old version, I just simply won't be able to log in, and it's my problem. But in Bitcoin, validators who do not update to the new versions of the protocol, they are in a way risking to jeopardize the whole network, because they do not participate in new rules, so they are left out of the process of achieving consensus. But even considering all of these facts, the history of Bitcoin shows that it is able to change and update to the needs of the community. So I am pretty positive that Bitcoin will transform in whatever people need most from it, and that it will be well, agreed by the community and not some single entity. So this is I would answer something like that, without
Thank you so
again
much.
giving too much of speculations.
Thank you so much. Is there anything in particular about the Bitcoin protocol that maybe like bugs you personally? The biggest thing that you would love to be changed, or you know, from the technical standpoint, or maybe for the community in general? Like one big thing.
Well, this is again very interesting questions. You're asking pretty interesting questions that you know, it's some kind of question when you need to think, sit and think, and like maybe remember your past experience. But yeah, nevertheless, it's interesting to stipulate on that. So I don't use Bitcoin daily for my like daily life. So it's not like I have too many problems or too many things that hold me back from enjoying the existence of Bitcoin. And I would say that, like, for me as a person, as the user, pretty casual, not hardcore user of Bitcoin, I would give it into the hands of the community and the core developers, because I feel that they know quite well what is the interest. Well, I mean, not what is the interest, but what is the positive course of development for Bitcoin. And if you are really interested to, have this a little peek into the future and check for yourself what is on the mind of the community, so what people are talking about and what do they want from Bitcoin, I highly advise to check. I will even send the link right now. I would propose to check the latest Bitcoin improvement proposal, because this gives the best overview of the possible course of Bitcoin. And by the way, core developers and community react to these changes also gives a lot of insight into where Bitcoin may go eventually. And here you can look both in hindsight what proposals have been already implemented, and you can even look have some foresight and look in the future what what are the hottest ones, for example, which ones are being discussed, or which ones are the newest ones and the most exciting and interesting from, for example, technical or societal standpoint. So yeah, I have sent
Thank you
link
so
into the
much.
chat.
Yeah, this is
hope
very
it
useful.
will-
I'll definitely go check it out. Thank you. Sorry, I was bugging you with all these speculative.
No.
questions.
It's okay. It's great to have a person who asks these unconventional questions, because it always creates a new food for thought for everyone in the group, not only the person who is asking. So you are doing also a very important part of this learning process. And thank you for these great questions.
Thanks.
Okay, so we have only a few minutes left. Yep, I see a question about proof of work to proof of stake, but it was answered. Yeah, well, nothing I can say to counteract or to back that up. So yeah, if you have no more questions, I propose we can finish today's session.
Okay, thank you so much, Alex. Thank you, Alexander, for help us. And thank you for all. And please wait for our quiz for you on this topic. And see you soon. Thank you very much.
Thank you.
Thank you,
Bye.
everyone. Bye-bye.
So much.
Bye-bye.
Thank you. Ciao.
Bye.